Good afternoon, everybody. My name is James Cousins, which I forgot for just a moment there, trying to get everything set up, but I think that you should be seeing what I'm seeing, which is the title of today's presentation, Predict Bootcamp Intermediate. And I'll situate it within context here in just a moment, but I want to start off by saying that I took a little bit longer than usual going through the registrant list for today's webinar and just peeking through to see, how many folks are joining us. And it's nice, it's really nice to see so many of our users tuning in. Obviously, you know that we're here for you on a as needed basis in the support capacity, but coming together in large groups like this is really exciting for us, for me, and also for my colleague Jeffrey, who is on the line now. So let me get this started after I, act all serious for a moment. Actually, hold on a second. Let me also say hello this way. So hi everybody again. And stepping back into it here, as you're all hopefully aware, this is the second instance of the deep dive Predict Bootcamp series. Last week, we went through some of the very basics of Predict, which included, several steps that I'll summarize in a moment. So we're in the second, and there is a third coming up. If you haven't seen previous instances, that's fine. Today's presentation is tailored to be a great starting point or to be a great point of continuation. When I go through this, there are a couple of housekeeping notes that I wanted to make sure everyone was aware of. The first is that we fully support and encourage and look forward to audience questions. The less planned this presentation can be, the better. So go ahead and ask your questions if you'd like to. Feel free to go ahead and toss something in there just to try it out and get used to it. We hope that people will use the feature there. When you do that, if you do that, you will also see a handouts tab available to you. And that handouts tab includes a copy of these slides. So everything I'm about to go through today is documented. It is available to you if you want to follow through or review that later. And the final, maybe the final housekeeping note is that if you're using a monitor that's relatively small or space deficient, then you might want to minimize my webcam so that you can see more of the text on screen and the screenshots. That is possible. There's a horizontal slider bar. If you grab that and you just move it up, you should be able to even completely minimize my webcam. However, for people who have been enjoying the human element of presentations these days, I'm here. Now, on to the actual presentation. This is the session description. I'm not going to read this, but I like to include it for posterity. Hopefully this is what you were all planning to see between 2 and 3 o'clock Eastern today. Today's agenda, I'm going to very quickly talk about Predict, and I'm going to summarize where we left off from the first instance of this series. And then we're going to cover all of these other techniques that were included in the session description. At the end, we will have time for questions, but in addition, you can ask those throughout, and Jeffrey will plan to stop me wherever they become relevant. So with that said, Predict, I think everyone on the line currently is familiar. It is a statistical exploration, predictive modeling software. Makes it really, really easy and really fast to find answers inside of your data. Maybe you have a question like, does this intervention actually translate to improved success rates? Or do people that look like this have a high rate of accepting our services, enrolling at our institution, having positive outcomes? You can do all of those things very quickly through this software. In fact, we did that, and everyone who was with us last time was able to see that process. What we did was we walked through a data set that was focused on higher education in this case, but a good example for any industry. Involved students that had been admitted to the institution but had the opportunity to enroll. That is to say, they might not have, but it's a favorable outcome. So the goal was to find out who would enroll, essentially what were the likelihoods, and to identify characteristics associated with that. So to support that, we looked at the variable statistics tab, which helped us to spot data issues, identify inaccurate means or variables that had excessive missings. We were also able to, particularly relevant for anyone who didn't know the data set, it was helpful to see the data mapped out visually through the multivariate analysis, the visualize tab, the lesser known name here. And then finally, we built a model. We did that automatically, but we also had some private, personal control over how it did that process. I went through that process, and then we memorized it and we saved our work. So because we did all that last week, we don't need to redo that this week. And I'm actually, similar to last week, going to show you most of today's content in the software. However, just a sort of public service announcement, I guess. A lot of effort was put into making sure that almost all of what you see today is very well documented and described in greater detail. So you should be able to use this as a reference in case I don't cover anything as deeply as you'd like. And of course, there's also the question and answer session. So without any further ado, I'm going to open up the software. I'm also going to remind everybody that in case they didn't know this about me, I do have dogs and I don't see them currently, which of course makes me suspicious. So if you hear any barks, I apologize in advance. Now, to get started with the software, this is the main screen of Predict. Everyone is most likely familiar with that. And I'm going to just talk about the virtue of having a nice, clean interface like this one, while I change the resolution of my monitor so that it is also a nice, clean, large interface like this one. So it should be a little bit larger. And now we're ready to get started. I mentioned that this is a fine starting point. So let me first start by saying that we have an analysis file that is the basis for everything I'm going to be doing today. If you are just joining us, if this is the first time that you've stepped into this series, I want to make a quick note that you can go to open a file, you can choose the text file, and then for brevity's sake, there are several ways to accomplish this. You can go to this location, which I'm going to chat to everybody. That location in chat right there, that is where the data set is based. And if you open it even right now, you'll be still well positioned to follow along with the actual work that I accomplish. So where I'm going to pick up is by loading the analysis file that we actually left off with in last week's installment. So if I double click on this, this is a really convenient way, like I had mentioned, to pick up on all of the work that you had done previously. Even though it's easy and fast, there are rarely modeling projects that do just require a single working session. So now I can go straight back to the model tab as we left it last time, and I can see both my in-state and my out-of-state models listed here. And the goal for today, because it helps to be working towards something practical and based in common user experience, the goal for today is to leave everybody with increased confidence in the model, more certainty about what it is that you have created and ability to explain what you've generated. And then the other goal is actually to go ahead and to improve the model. So to actually make the model better at the same time as understanding its ins and outs. Obviously, that's primarily based in the capacity to interpret your model results. So let me remove that model options there. And what you're looking at here is a pretty standard layout, but I want to walk through it just piece by piece. Along here on the left, what you'll see, actually, my fuzzy memory is coming back to me. I did want to ask as the first chat option, the first question to you, the audience, um, what are your go-tos when you're trying to decide if a model is satisfactory? I think it'll help to set the stage if I know what you all typically look at when you're using the software, and then I can possibly even pay a little extra special attention to those things. So when you're building a model and you're trying to decide if this is good enough, if this is a model you want to move forward with, what do you go to? What do you use as a decision rule? And I'm gonna bring in my assistant, Jeffrey, or wherever. I don't know where he would be positioned, but I'm gonna ask him to let me know if there are any answers coming in.
Yeah, we have a great answer here that someone says, let's look at the concordance score.
Yeah, that's a great one. And we're definitely going to talk about that. And so that I don't forget, you can also find a discussion of the concordance here mapped out visually. So I'll talk about it, but also know that we've provided a resource there too. Any other competing decision rules?
The bar graph that's over on your right.
Perfect. Yeah, the decile analysis is a great resource.
And specifically, they want to see evenly stepped down deciles. Another user asked about or they mentioned that they like to look at the adjusted R squared.
Yep, that's another one. It's awesome to hear that there are so many different different perspectives as far as what gets used. What we've done over the years of development with the software is we've added features as they are requested and as they become apparently necessary. And so we have a lot of different ways that you can explore any models that you've built. And so it's good to hear that they're all used. I do want to use those points of reference and start to talk through how to interpret those, especially if any of those terms were unfamiliar to anyone in the audience or maybe just need a little bit of familiarizing. The first thing I want to point out is that when you load an analysis, typical behavior is to try and maximize the amount of space that you have to work with the data. So you may notice that the analysis info was shrunk. And so if I do expand this, this is a really important, for me anyway, this is a really important step to take when loading an analysis, especially after a while, because sometimes if you set a filter, as we did, then it will remember that. And as you're starting to build automatically, you might not realize, for example, if I go ahead and show more here, it's telling me that the current filter is for when in-state is 0 for out-of-state students. So to make sure that as I'm exploring these things, I'm looking at the entire modeling population, I'm going to open up this filter node one more time, and I'm just going to clear out that filter so that we're working from a clean slate, as it were. And with that, I can see that I'm using all of the records in my data set, and I'll go ahead and just rebuild a model automatically here so that I have an overall model. So let me go ahead and do that. And oops. Now I'm going to work through the process of talking about its interpretation. So I shared with you last time that one of the quickest ways to get a sense for the model is by understanding the variables that are entering it. So if you mouse over any of these, you do get this thumbnail. But something that people tend to want to explore and want to be able to share and talk through confidently is this down here, this regression model with definitely many more objective metrics, numbers and readouts like that, which is not the most intellectual thing I've ever said. But whereas here you get this visual overview of the athlete flag, in this view, I can see a couple of other things. So the athlete flag, the athlete binary, is coming in with a coefficient, which is this first column, of 0.97, etc. What I would love to leave you all with is the fact that the actual coefficient, the 9.7 versus 9.5 or 8.9 or even 1.4, a lot of times that's not the most important takeaway from this. The most important thing that you can gather from this is the fact that it is positive. Um, Being humans, the difference of a few decimal points is not going to really give us something solid to grasp onto. So instead, if you look at this and see that it's a positive coefficient as opposed to this field, which is a negative coefficient, the positive indicates that it is a positive relationship. That is, as athlete is true or athlete increases, which doesn't make sense for binary, but for something like the days between app and term start, as that increases, if it's positive, that means that your outcome is more likely. Enrollment is more likely when the person is an athlete. And if it's negative, then enrollment is less likely. So in this case, the further out somebody applied, the more days between the application and term start, the less likely they are to enroll. So that's the first thing to be confident about, is what that coefficient means. And then I would say the second most important thing to be confident about is the significance of these p-values and chi-squared scores. So there's an inverse relationship between these two fields. The chi-squared score, which will be different. It will be a different test if you're using a continuous outcome like GPA or giving amount. The higher this test score is, the more certain it is to be a true relationship in your data. So bringing that up to the practical level, in-state is relatively more certain to be an actual relationship between, for instance, in-state and enrollment, than if you're looking down here instead at the department code, political science. This has a lower test statistic. It is still significant, but it is less certain to be a true relationship in your data set. That corresponds to the p-values. So the higher the test statistic, the lower the p-value. And I want to make sure that I don't discuss technicalities for technicality's sake. The upshot of this is that when you're reviewing the variables that enter into your model and you're trying to develop a sense for, what's really explaining this model, it's a question that we commonly get in the support side. They want to just understand how much of the model is dependent on this field or on that field. This can help you to get a sense for the really significant relationships versus the helpful but less significant relationships. And from the business perspective, that gives you a lot of leverage to answer important questions. So maybe, if you have the, how should I say, the capacity to increase or to act on one of these fields versus the other. So in-state students with this incredibly certain relationship, this really is worth some time, some resources, whereas others, which are less confident, if you have to pick between them, maybe that's evidence to not invest so much in attracting students with a higher high school percentile. Not perfect examples, because these aren't really, this one anyway isn't really an actionable field, but that's the upshot for people who are wondering how they can use that more strategically.
Hey, James, we actually have a question here in talking about the variables included and not about this view new variable suggestions checkbox.
Yeah, absolutely. So let me see if I can draw around that. I think I can. So what Jeffrey's mentioning there, what the person was able to spot, kudos, was the view new variable suggestions box. And let's just erase the rest of that drawing. That did not go any better after the first one. So that feature, what it supports is the ability to not just see the continuous and the binary fields, but also the automatically generated fields from the software. So I think that I mentioned in the last session that if you have a categorical field like department code or admit condition or donor category, any of these things, that you don't need to do much data prep to those. typically, because it will automatically generate suggestions like a flag for the communications department or the economy. Uh, uh, yeah, econ major. Sorry, that sounded weird because it's so often abbreviated to just econ. Um, so it's generating these for you, and when you say view new variable suggestions, it's just giving you a unabridged list of those fields. So that's always useful when you're trying to get a sense for what's available in your data set. It's a great question. However, all of those, of course, working themselves into the model and then seeing some of these readouts, that's how you would start to understand them. So if something like the first gen flag entered into your model, then you would be able to see exactly that relationship. And this is, I think, an interesting, maybe an interesting time for a potentially unplanned pop quiz. Can anybody in the audience see any issues with using first gen flag based on this readout, now based on knowing what we know about the values here? This is a bit trickier. So I'll just pause a moment. While people think about that, while people send in their responses, sort of just taking a last scan at this, I do want to very quickly mention the decile analysis. The decile analysis, it's a visual indicator of how the model's doing. And so when you're looking at this, what you're hoping to see is that the first decile has the highest rate or the highest score. And there are other ways to explore exactly how that decile analysis is built. And I'll just pop over here to show you that we've created this nice flow chart that explains it all. But the long and short of it is that the model, when you use a holdout sample, it scores that holdout sample and assigns rankings, assigns records to a group based on what it expects. If somebody is assigned to the first decile, it means that the model expects them to have the highest rate or the highest score. So when you see, and I should show you this here, the show actual and predicted. The blue is what the model expected. That's the prediction. The green is the actual, and that's what we show you by default. So whenever you see that the group expected to perform the highest did actually perform the highest in the holdout sample, this is a good sign for your model. So when you see this where the first is higher than the second and the second is higher than the third, this is generally a good thing to see, and it's what you want to look for. There are some exceptions, and maybe I'll have time to get into those as well. But for now, I want to turn back to the first gen flag.
Yeah, we have a really nice scientific answer that says there's a negative relationship between the coefficient and a low chi-square value. But I think one of my favorites of the many people who mentioned the p-value is it's atrocious. It's an atrocious p-value. So, and I agree completely. It's greater than 0.05. So
That's exactly, I would say that that's the primary reason why I would exclude it. So the answer, just to rephrase it as well, the reason why this would be concerning as a contribution to the model is because the p-value that's listed here is 0.039, which means, to call back to the first week here, that there is a 39% chance that the relationship that was seen in this data set could have happened randomly. And if it's that likely to happen randomly, it's not something you want to bet a dollar on moving forward. So this is not good. And of course, that's why when you build automatically and it doesn't allow things that are unrelated, it will not use that. So all good there. That's great.
yeah,
Glad that the quiz was successful there. I
there
want
was
to, oh, go ahead.
There was one more question. Someone asked, can we say that the highest coefficient and highest chi-square means that the variable is more significant?
Man, I was trying so hard not to sound like a statistician today. It depends. The reason it depends is because you can see here, as an example, that in-state has 1.1 coefficient. That's pretty big. It's over 5 times absolute value. It's over 5 times the size of the new days between app and term start. But something to think about is the fact that square root is going to travel more than in-state. In-state goes from 0 to 1, so it only ever shifts from contributing nothing or contributing 1.1 to the score for any given record. But here the square root, if this increases even just 6 times, then all of a sudden that's providing a larger contribution to the record score. So it's really hard to say based exclusively on the coefficient. However, there is a field for that. So I'll go a little bit out of order. I'll just jump straight down to that because it just so happens that there is a readout that is entirely dedicated to trying to communicate the impact of a given variable, and that is the percentage model contribution. I might have covered this last week, but it's worth reiterating here that this readout means that the high school percentile, for instance, contributes 31.2%. However, whenever it's an interaction term here, like there's the high school percentile and the square, for the most part, these can be summed up. So as it turns out, high school percentile, if I scroll up here, that's a very small coefficient. And yet, if you take a look at this, it's contributing a lot of the variation from any given record to the next. So this might be a resource to turn to for anyone hoping to answer that question. You can also see here that in-state is a significant contributor and square root, and then it starts to trail off as you're looking at political science. I promise I did not doctor this data set. There's no attempt to pick on any particular major, but that's a useful way to explore that percentage model contribution. The goal, and hopefully we're moving further towards this goal of getting more comfortable. If you generate a model now, you can read it and you can understand what's going on. But we also wanted to talk about how to improve the model. And part of the modeling process also involves some choices, like do I split the model into 2 different groups or don't I? And so to answer that question, I'll start to address percent concordance. This is a very useful metric, especially when you're trying to compare multiple models that are used for similar purposes. So this 68% that you're seeing here is indicating that 68% of the time, whenever there were differing records, the model picked the record that did enroll as being more likely to enroll. Shouldn't surprise anybody. This is also supported. Oh, I already showed you this anyway, but this is also supported through this diagram. For present purposes though, the reason we want to make note of this is because here is an overall model which reflects in-state and also out-of-state students, and it is has a 68% concordance readout. So if I memorize this model, fortunately, last week we built an in-state and we built an out-of-state model, and now our goal might be to compare multiple models. We want to build the best model that we possibly can for all of these features. So the question is, does an in-state model do a better job of modeling in-state students than the overall model does? And one of the easy ways to answer that is to, for instance, see the percent concordance here. Note that it's 68%. I will also say, just for completion's sake, that the pseudo R squared, that the Somers D, GK gamma, Kendall's tau A and C, even though it sounds like a huge variety of different metrics that you could use to base your decisions off of, these are, well, so to address it directly, the C statistic is based off of the same calculations that the percent concordant is. So these 3 the concordance and discordance, this is related directly to the c-squared. And more to the point, the rest of these are all basically just different ways of calculating the C statistic. It's if you use a different denominator or a different numerator. So they're all very, very similar, and it just is an issue of which do you feel most comfortable using. And once you find that one, it's often perfectly acceptable to stick with that as you compare multiple models. So that's what we'll do. And when we do that, if I open up the in-state model and I take a look at the percent concordance, I would advocate also looking at the variables that entered into the model, but for present purposes, I'm mostly concerned about this percent concordance as a shorthand. And I see that it is not as strong, that it predicts it's 5% less concordant essentially. And there remains some chance whenever you're building a model for in-state students and out-of-state students, what can sometimes happen is that it's way better for the out-of-state students, even if it's slightly worse for the in-state students. Hopefully that makes sense. I don't want to assume I don't want to assume that everybody's tracking exactly along with my reasoning there, but sometimes an overall model is not very good for group A, and it's fine for group B, but if you separate them out, even if you take a small hit on one of the partitions, you might be improving things for the other. So let's take a look. And sorry, I was supposed to act surprised, but I did know that this was going to happen. It's not as good as the overall model for either group. And that should be the first clue that maybe it's not actually going to be a helpful strategy to split up these groups. And thinking back about the storyline that follows through all of this, the reason that you might have been going through this is because admissions, or if you're in a healthcare setting or if you're inside of a fundraising setting, there's always hypotheses that your colleagues and that stakeholders are going to have about how to approach the analysis. And it's worth testing those. So you might have, in this particular scenario, based on admissions observation that in-state students and out-of-state students are treated differently, maybe you would want to entertain that hypothesis. And here you would have seen that it's not effective, but we can start to find out why with the support of the Visualize tab. So whenever you separate two populations like this, typically you would do that because you suspect they behave differently. So maybe there's something significant like days between app and term start that is driving in-state students to act one way, and that same relationship for out-of-state students is opposite. So maybe the further out that out-of-state students apply, the more likely they are to enroll. So you would check that using the Visualize tab. And you can, by the way, pick this up for anything. If it's students that are receiving financial aid, or if it's people that are inpatient versus outpatient, or new donors versus returning donors. Again, it does apply to every industry here. So if I take a look at that days between app and term start, this is the relationship for the group overall. Again, no filter set here. So now this is a feature I don't believe I mentioned last week. I can view by. And if I do go ahead and view by, the question is, should we build a model for in-state or out-of-state students? So if I view this relationship for each of those groups, I can click here in-state. And this, whether or not everyone sees it at first, this conveys a lot of information. So let me increase, and I also don't want to gloss over any steps. In order to make this visualization easier for me to follow, of course, you can always use the visualization options. This case, I'm increasing the point size just so that it's more apparent, but I also could change the color scheme, or there are actually some that the analysts themselves built. And oh shoot, I think This is a homage to my colleague, John McMillan. So hopefully these are distinct enough colors, but this top row is in light green here, and those indicate in-state students. And this lower row, this is the pinkish shade, and those are out-of-state students. Now, what we're seeing for the in-state students is that this relationship, which is significant in our model, is a negative one. The further out the application is, the less likely they are to apply. We would want to separate these two groups, for instance, if this relationship looked different for each of these two populations. But what we're seeing here is the same exact response. That is to say that for every increase in the number of days between the application and the term start, you see a very similar decrease in enrollment likelihood. And what that tells me is that even though these are different groups, they are actually behaving and they are motivated in the same way as each other. And since this is a significant variable, we could explore any of the other ones that are used in our model. What this tells me is that it's pretty safe to include both of these groups in the same modeling population. This type of investigation, typically you want to go through a couple of different types of questions here. But before I hop off of this, and maybe as another quiz to the audience and trying to keep myself honest on time, I do want to ask, there's something kind of interesting happening here with the number of days between the app and term start. There's this little spike. I'm curious, just in the audience, is there any sense of why something like that might be happening? And do you have any concerns based off of that? And I'm gonna leave that as an open item. Just as a heads up, still to come, we are definitely going to be talking about the clustering analysis and how that's going to help us to improve the model. I'll show you how to spot some of the possible areas there. But before I get to there, Jeffrey, do we have any responses?
Yeah, someone asked, is it significant about the date to pay tuition here? And there was also a spike due to early acceptance deadlines versus a final deadline.
Yeah.
Which is something that I want to include in my modeling from now on.
Yeah. Yeah, it is the case that sometimes people are inclined to use, admit type, application type as a factor, but I'm again glad to hear that that's how people are interpreting it. A big part of what helps you to go from just managing to produce the model to really owning the model that you built and explaining it and looking for new ways is, this might have seemed like an isolated exploration, but looking at the relationships like this as you build your model and critically trying to figure out what is happening is typically the cause of finding new fields that you can use in your data sets to improve your model. So that's why I wanted to walk through this. The going hypothesis internally is that this has to do with application deadlines. These people that applied last minute are most likely, and this might represent the last minute version of early action applications if people have differing application types at their school. So that's great. Good catch, audience. So with that, just to recap very quickly, we're able to interpret what's going on in the model that we've built. We're able to come up with a data-informed reason why separating these populations is not the best play. And also, we can explore that and prove that through the Visualize tab. So a lot of things to put in the back pocket there. And now that we're confident about the models, the goal is to improve it. Haven't really rehearsed this part of it, but thinking about some of the rules of thumb on how you can improve the model. One, is if you can find more records that uh, that are qualified in the same way. So if you can find maybe an extra year of your data that can maybe shed light on some more loosely defined relationships. So more data can sometimes help build a better model. You can include more characteristics. That's another way. So if you have access to a completely different system that you want to merge in, like student interactions, or if it's a healthcare resource, or if it's mobile app usage, or you probably know of several relative to your industry, but more records, sometimes helpful, often worth exploring at the very least. More data points, or variables, I should say. And then the third, which is what I'm about to explore, is augmenting your data set, which if the last several articles that I've read on LinkedIn are to be believed, is the the current term for transforming your data and for creating new fields. However you know it by, if you have 21 characteristics, it's often the case that you can use a combination of your subject matter expertise and a formula to calculate a new way to understand your data. And there are all sorts of ways that we might be able to do that using a transform, but I think a way that's much more convenient and something that the software supports very well is clustering. So I really like this feature because I think it's one of the most creative aspects of the software in terms of what it allows you to do. Because this uses k-means clustering. So if I'm looking at high school percentile, just as one example, this could be high school GPA, this could be score, you name it. These are all continuous fields. And so if I pull this over, you'll see off to the right here, there's a number of clusters option. My typical starting point is 4, but you can obviously choose anything from 2 all the way up to 10. Unfortunately, because it's a common question, there is no rule of thumb, across the industry. Some people say that you should have a cluster for every 100 records. Other people, recognizing that gets out of hand pretty quickly, say that, just a handful or single-digit amounts are always acceptable here. I use 4. I recommend you start with 4 and see what the data points to. And if you generate those clusters, this feature, it finds the 4, because you've defined that, the 4 optimal means in the data set. So it's determined that if it identifies one group centered around 39.2, another group centered around 63.2. Oh, good, there's only other, those are the only 2.2s. These are the means that help to minimize the distance from any record to its nearest cluster. So it's a really interesting feature. It's an established algorithm, but the upshot, again, keeping things in practical terms, is that when you step into a data set, you might not always know if it makes sense. Do I cut it off at 50, and then I go 50 to 60, and then 70 to 90, and then 90 to 100? These rules are sometimes arbitrary. To avoid that, you can let the k-means clustering tell you where it sees the most efficient cutoffs, and then if you click in this field here, you can use this as a factor in your model. So I'm going to call this my high school percentile. Not that I love all caps with underscores, but high school percentile clusters. So if I create that field, and I can create as many as I want, now I'll take a brief detour over to the model tab, and I will look at the auto mine feature. Sorry, lost my place for a moment. And just take a quick peek at the newly added high school percentile clusters. It's exciting. It is related. And if I'm taking a peek here, it's, I don't know exactly how impressive a 23 test score is, but what I can do, for instance, is I can compare it to the untransformed version and see that actually maybe this does not have more significance than my original term, and that's okay. It's a very experimental and, as I mentioned, a very creative process. But before I go to the next aspect of the clustering feature, I was really curious to find out the next aspect being that you can use 2 or more variables as well. I'm curious of the audience, has anybody used the clustering analysis in their models? And if you have used the clustering analysis, what have been some of your most successful groupings of things, groupings of characteristics? And while those answers are coming in, I'm just going to set the stage for, well, I'll wait. Take a drink from my Mio water. It's nothing else. It's just Mio water. Anything from the audience there, Jeffrey?
No, not yet.
All right. Oh,
Yeah, someone just comments that males and females often behave differently. Clustering helps to quantify this relationship.
That's interesting. I would love to follow up and see how that's been introduced into the data set. I would imagine there are probably a few different ways. Well, as more come through, maybe we can circle back towards the end of the presentation. I do think that this is a relatively lesser used feature, but why I see it as something that's so valuable for your analysis is that a lot of times, maybe you've wondered or heard or asked about interaction terms. This idea of not using individual characteristics at a time, but using multiple characteristics as a sort of battery or as an aggregated score. So something that I often recommend as a good starting point is thematically similar fields. So like days between app, or I should say new days between app and term start. This essentially boils down to a measurement of engagement, or it could be interpreted that way. And there's this other field in our data set, the distance from campus, that while it's been impacted by the pandemic, it is also a measurement of engagement. How physically close is the student to your institution? And just on the hypothesis that there might be some kind of relationship, you could also build this cluster. And here's where you can start to see, just as a quick note, I can also reorganize my screen here. So I'm just gonna click and drag this off to the left, and that's gonna help me to see this graph a little bit more easily. And from here, it starts to become clear that when you use more than one field, you can see groupings like this group here, which regardless of distance from campus, encapsulates all of the what we might call late applicants. And then off to the side here, another group entirely has been defined as basically all early applicants. I should say they're the distance travelers, it looks like, is actually the defining characteristic. So it's pretty much every group of people that came from the furthest away. And then these other two groups that you have here, these are those that are a little bit closer to campus, but intermediate as far as how early they applied. And then similarly, this other group. And when I mentioned it's a creative process, this is really why, is because this can sometimes put into data what you might have described in words. Another common example is people who have high test scores but low GPAs versus high GPAs and low test scores. So this creates one indicator of more than one characteristic at a time. So I won't belabor the point. Let me go ahead and actually save this. This is I'll just go ahead and call it my engagement cluster. It might be good practice to name the cluster after the multiple things that you've included, but I'll go ahead and create this here and go back and check out my modeling tab.
James, we have had a few questions come in about clustering, And
Oh,
someone
great.
did say that for the previous question about gender, to assign numeric values like 1 or 2 to male or female, and that will help you with
Hmm.
the clustering. Someone else also asked, could we use this for propensity score matching?
Oh,
And I have at least 2 other questions too about could we allow the algo to automatically select the best number of clusters? And can you cluster with all the variables and then allow it to select the variables for you?
oh, okay. Wow. So I don't have tidy answers for all of those. I do now see how to use how that one person was using the gender aspect for the interaction term. There is not a known way that I am aware of to let the algorithm decide on the number of clusters. Um, it would be very cool, and it's probably something I'll delve back into. Um, but uh, I also think, well, I have some other thoughts about it. Maybe I'll be able to circle back on that. Um, then the last bit about using all of them. So there is no parallel that I'm aware of to, for instance, adding everything and then letting it choose in the same sense that the model might go through that process. So unfortunately, the answer is no there. But I think that that's a good thing personally, because the primary reason for clustering is when you have appropriately linked fields coming together in a single indicator. Because, and I think that this might be one of the best tips that I share with anybody throughout my entire career, you shouldn't forget that you have to be able to explain your model. And so if you end up with a cluster that combines what shouldn't actually be a continuous field, but if it combines citizenship code with their student ID, if it does help your model, you have to somehow make sense of what that means about your data and how that can inform any kind of action, um, typically speaking. So I think that the fact that you can't toss everything in and then let it sort it out kind of stems from the fact that variables have significance. And as subject experts, you know the significance of those fields. Um, However, just to avoid a rush on the tail end of this presentation, I do want to very quickly try to rebuild the model automatically and see if our latest cluster entered. Um, and it looks like it did. That was also my surprised acting. Thankfully, we did have a chance to run through this ahead of time, and we were vaguely familiar with this entering in. But this speaks to the other aspect of our goal. You know, the whole reason for spending more time in your data set than you have to is to try and understand the model better and to build a better model. So through the things that we've discussed today, fortunately, we were able to accomplish both. And it's a sample data set, full, I will fully concede that point, but this really is emblematic of what happens when you do spend a little more time with your own data, is that you can use these same techniques and you can arrive at the similar or same conclusions. Um, I want to make a brief nod because sometimes there are other logistical things that you need to do. Um, I was going to give this a little more attention, but fortunately it's inside of the PowerPoint. So let me just quickly run through it there. Um, Again, you'll see walkthroughs for all of these things. I was also going to shed a little bit of light for those looking to improve their models by modifying the holdout settings. Holdout setting is just uh, the proportion of the data set that the software uses to build the model, and then on the other half of that data set, in this case, it will test the model. So it's generally good practice, but if you have a very small data set, sometimes you need to increase the modeling sample and potentially not actually use a holdout sample. When possible, 50% is great. And that also is a great way of describing the p-value setting. By default, everyone should notice that it's at 0.01. You can change that default, and you can also change it on an as-needed basis. But 0.01 is a great operating default. 0.05 is also definitely fine if you have a smaller data set, or if you have maybe just even just a harder to predict behavior. Some things like giving a major gift in the fundraising setting, or graduation, there are so many human elements involved that the correlation between a measured characteristic and that outcome might just not be as strong. And that's okay. And that's why you can increase the p-value threshold to try and explore those things. I didn't leave as much time as I wanted for questions, probably on account of how much you talk, but I'm glad that we got to some throughout, and we do have at least a little time. Stay tuned for the third as I now turn the page to prompt for questions.
So we do have a question here. Would you recommend using a holdout sample to validate the model, and then use 100% of the data for modeling to optimize your model?
Yeah, it's recommended for sure. That's actually, and the last bit, just to highlight the importance of that suggestion and the phrasing, I often do that. A lot of the times, in order to build a model and test the data set for consistency, if you have a 50% holdout sample when you build the model and you see good results on the test, these relationships do fairly indicate how the holdout sample behaves. And these, I should also mention, these test statistics, these are all based off of the holdout sample when you have one. A good next step, or at least an interesting next step, would be to then build a model on the entire modeling sample, and maybe even just see what else enters in. You will, I think, almost always see that more variables do enter in because you have more data. But if they are similar to what has entered previously, you probably are safe using this as a production model, as it were.
We have one other question about preparing data for modeling, not just how to use construct, but what types of things do we want to do to get the data ready? For example, how to handle missing variables, and when do we have to transform variables?
You should always report missing valuables to an authority somewhere.
Sorry.
I will start at the highest level, the most necessary level. You should always have an outcome. You need to have something built that measures what you're trying to predict. Sometimes people will have something like current student status or current prospect status or something, and being familiar with the data, that one of the code values represents what you want to investigate. The only thing you need to do is you need to build a binary that indicates that category, or if you have a continuous field, that's fine. But those are the two things that need to happen ahead of time, is that you need to have an outcome that's binary or continuous. Outside of that, I even recommend that you don't always need to go crazy with data preparation before you get to this stage, because sometimes this is a quicker way to learn about what's going on. If it's missing values, which is mentioned earlier, or if it's even just strange relationships. We actually had an instance of that in the last session with the days between app and term start. We noticed this, and we took care of it after we picked it up in this visual format. So you can definitely do some things ahead of time, but you can also turn to the application to help you spot some things to save you time. And I do see that we're at the top of the hour. If there's anything quick, Jeffrey, feel free to ask it. Otherwise, can certainly thank everybody for their time.
I just want to say thank you for all of the questions that were asked today. Folks were really, really active. And if I didn't get to your question, my apologies, but we will follow up on these on the back end.
Yeah, we absolutely will. And make sure to register for part 3. It's going to be exciting to see if I run over in that one as well, or if I stick to the time schedule. So make sure to register, and we'll see you there.
Thank you, James.
Thanks, everybody.